All right, so we have another claim, this time with matrices instead of polynomials or vectors, and the claim is that these four matrices that we see written here, 2, 0, minus 4, minus 2, etc., that they span M22. And what that means is that, again, if we think of matrices as being vectors in this space, is that I can combine these four matrices together somehow to get every single other matrix in M22. So, if I want to write that as an equation of some sort, what I'm claiming is that, again, just like with polynomials, that or vectors, that I can take that I can go to M22, I can pull out any matrix M, any 2 by 2 matrix, and no matter which matrix I pull out, I can always find a y1, y2, y3, y4. And so maybe I should say has a solution for every m in M22. That means no matter which m I pick, this polynomial or this matrix equation here always has a solution. There's always a y1 through y4 that'll make that work no matter which m I pick. Alright, so the question is, what should that be? So once again, I don't know what the entries are of the m that I'm looking at, so I have that. But this is what I do know. So let's say m is question mark, question mark, question mark, question mark. What I do know is the top left entries should all sum to this first question mark, right? So in other words, 2y1 minus 4y2 minus 4y3 minus 3y4, that should be the same thing as this first question mark, right? And so on and so forth. Top right, 0y1, 4y2, minus 4y3, 0y4s should be the top right here. I'm going to go ahead and move through the remaining coordinates. Alright. So allegedly, what we want is to show that this system of equations always has a solution no matter what's sitting in these question marks. And as we recall from when we did this with regular Rn vectors, our goal is to take a reduced row echelon matrix and to see whether or not we have a zero row. If we have no zero rows, awesome, we can find the solutions we need. If we have a zero row, not so great, there are things sitting outside of the span. And so, as usual, I can ignore that, and what I'm looking for is the reduced row echelon form of this matrix here. And let's see what that looks like. So 2, negative 4, negative 4, negative 3, 0, 4, negative 4, 0, negative 4, negative 1, negative 1, 2, negative 2, negative 3, negative 3, negative 5, and we have that the reduced row echelon form is in fact 1, 1, 1, 1, zeros abound. Alright, so that's a reduced echelon form. And so what that's telling us is that now if I put back my question marks, that whatever is sitting in those entries, there is a solution to that. And so these vectors do in fact span M22, since there is a solution for every choice of M to the above matrix equation. These matrices span M22. Alright. Thank you very much. I'll see you in the next video.